SVM parameter tuning, we have to just provide the value of C, as well as we have to just provide the value of kernel parameter. So whatever the kernel function you are using, you have to provide the value according to that. Now another problem with the SVM, that is actually maybe your data set will have actually class imbalance. So in SVM, otherwise before develop the model using the SVM algorithm, we have to just handle this class imbalance. Now the question is, what is class imbalance actually? What is class imbalance? So let me firstly discuss class imbalance, and after that how to handle that class imbalance. So now what is class imbalance actually? So now many practical applications having class imbalance, but still the question is there, what is class imbalance? So let me just take some examples. After that we will discuss, otherwise we will conclude what you mean, what is the meaning of this class imbalance. So here we have two things, detecting fraud transactions and cancer detection. So now guys, consider we have actually 1000 transactions, and from this 1000 transaction, 10 transactions actually a fraud transaction, and 990 transactions are actually a right transactions, they are not the fraud. So now in the data set of 1000 in the data set of 1000 elements or 1000 rows, 999 transaction having actually true label, okay, and 10 transaction having actually false label, 10 transaction having actually a false label. So that is actually known as highly imbalanced classes. What do you mean by class? Class is nothing but a class value or labeled value. That is actually known as class value or labeled value. Okay, so I have actually two class labels. In short, I want to work with the binary classifier problem. I am dealing with the binary classifier problem. So in that actually I have only two class labels, true and false, otherwise fraud or not a fraud, or genuine, fraud and genuine, only two class labels are there. But how many records says true? So 990 records say, oh, that guy is a genuine, and 10 records says actually this guy is a fraud. So guys, that is actually known as a highly imbalanced. Why it is known as highly imbalanced and why SVM has to deal with the imbalance firstly? Because now consider, like you have 990 records on either of the side of the SVM. Okay, so here I have actually 990 records. Let I just draw 9 records only, and I have only 10 records. Let I just draw only single record on other side. So now how to draw the margin value? How to draw that SVM? So guys, let I just draw the SVM. So मुझे maximum margin चाहिए. अच्छा, मुझे मैक्सिमम मार्जिन चाहिए, तो यहाँ पे मैक्सिमम मार्जिन मतलब एक ही बंदा है, तो मैक्सिमम मार्जिन वाला कंसेप्ट कहाँ से आएगा? So that's like an issue. Otherwise, consider you have 10 elements, you have 10 attributes, or like 10 or 20 attributes, so that makes an issue. Now consider if this guy having some noisy data. This guy having some noisy data. Let I say let it has actually 990 records. Okay, this is actually 990 records. So हो सकता है कि यहाँ पे मेरे पास 4 या 5 वैल्यू में noisy data था. Otherwise, like that's not actually properly labeled data. So 5 element इस तरीके से. But जब आप SVM draw करोगे, now the SVM will be something like this. Because here on the right hand side we have only single record, on left hand side we have actually 5 records. So as per the number of elements in either of the classes, SVM will, normal SVM, actually default SVM formulate that that's actually highly skewed hyperplanes. Highly skewed in the sense highly actually impositional. Ensure I just say actually wrong SVM it will just throw. So that is the problem with the SVM. So what we have to do? We have to firstly balance this data set. Okay, class we have to just handle the class imbalance actually before just applying the SVM. Okay, so firstly, what was the problem with the SVM? SVM cannot work with the categorized data, so हमने उसको numerical में map किया. After that, before starting the SVM, we have to just provide the value of parameters. The first one is actually C, that's mandatory if you have a noisy data, and that's in real world you will get a noisy data, so consider C is actually mandatory. Another thing is we have to just provide the kernel parameter value, so it depends on actually whatever the kernel function you are just trying to apply. So if you want to apply the polynomial kernel, then you have to provide the value of D. If you want to apply actually RBF kernel, then you have to provide the value of sigma, or you can say that gamma. अगर आप tangent kernel apply कर रहे हो, then you have to provide the value of kappa and also the sigma. So it depends, parameter values depends on the kernel, whatever the kernel function you want to apply. But what was the next problem? The problem is, consider you have a data set, but that's actually highly imbalanced. not the data set, but class labels are highly imbalanced. In short, 990 records, let me take an example. So in our example, 990 records say, oh, that guy is genuine. 10 records says, oh, that's not a genuine, that is a fraud guy. Then what to do for that? So that's that thing we have to manage. That thing we have to manage before just trying to develop the SVM model. I was trying to develop actually model using the SVM algorithm. So how to manage this? So we have two options: either down sample or upsampling. To manage this highly imbalanced data set or class imbalance, we have two options. Either you can downsampling or you can just upsampling. So what is the meaning of the downsampling? What is the meaning of this upsampling? डाउन सैम्पलिंग इन द सेंस व्हाट, जिसके पास लार्ज डेटा वैल्यूज था उसको एक्चुअली स्मॉल डेटा वैल्यूज में कन्वर्ट करें. इन शॉर्ट मेरे पास अभी एग्जांपल के हिसाब से मेरे पास 990 रिकॉर्ड्स थे, ओके, एंड दैट्स एक्चुअली ट्रू, एंड वी हैव एक्चुअली 10 records that actually says false. Okay, that actually says false. So what we have to do, अगर डाउन सैम्पलिंग कर रहे हो then randomly choose only 10 records from this. Okay, so डाउन सैम्पलिंग में यहाँ से 10 records चूज करेंगे जिसका लेबल ट्रू है, and we have actually 10 records in actually false, 10 records with actually false label. So now it's equally actually divided in true and false parts. So now we can just draw a proper SVM. But that's not a good idea to just choose the 10 values from 990 values. That's not a good idea to just choose a 10 values from the 990 values. So guys, अगर आपके पास हाईली डेटा सेट है, मतलब लाइक इस तरीके से डेटा सेट है जिसमें एक साइड बहुत ज्यादा वैल्यूज है, then down sampling is not a good idea. Then let me just discuss this upsampling. So upsampling में क्या करेंगे, 990 डेटा सेट को, अदरवाइज मतलब जो 990 वैल्यूज थी उसको हम एज इट इज रखने वाले हैं. ओके, नाउ दिस 10 रिकॉर्ड्स आई वांट टू जस्ट, मुझे दोनों सेट में इक्वल नंबर ऑफ वैल्यूज चाहिए, तो ये जो 10 रिकॉर्ड्स है उनको मैं 990 टाइम्स लिखूंगा. ये जो 10 रिकॉर्ड्स है उसको मैं 990 टाइम्स लिखूंगा. ओके, सॉरी, 10 रिकॉर्ड्स के एक्चुअली 99 टाइम्स यूज करूंगा. रेप्लिका जनरेट करेंगे, डुप्लीकेट वैल्यूज जनरेट करेंगे. Okay, so now that's actually known as upsampling. That is actually known as upsampling. So this is the way to deal with actually class imbalance. That is the thing. But now how actually SVM works? ये process हम लोग कैसे करें SVM में? So what was the formula? As we know, to just maximize the margin value, the formula was actually we have to just minimize this W square by 2. So this is actually a formula: minimum the value of W, minimum the value of this thing where you have actually the value of W and B is given. So 1/2 actually W square plus, now plus करके हम जो लिखते थे वो क्या था, ये क्या चीज है guys? That is actually nothing but a summation of the slack variable. What is the slack variable? That's actually like slack variable is nothing but an actually distance between margin and actually wrongly classified, otherwise noisy data actually. So now what we have to do, here we just write down C. What is that C? That's a parameter which we will provide, divided by n plus, and here C divided by actually n minus. What is that n plus and n minus? N plus in the sense number of elements which is positively classified, otherwise positively labeled. In our case, let me consider this 990, otherwise let me consider this T as a positive label. So here we have to just write down 990. Here we have to just write down 990. And what about n minus? That's actually a number of elements which is actually negatively classified. Consider you are working in a binary classifier. You are just using, you are dealing with the binary classified problem. Then you have only two labeled data, either positive or negative, either yes or no, either male or female, either fraud or not, either fraud or genuine, like that. Okay, so here in negative we have 10 number of elements according to our example. So here you have to put the value of 10. C will be same in both the cases. C will be same in both the cases actually, and that value we have to choose as we discussed in a previous slide. Okay, now what about this what about this sigma, where actually j starts with actually yj and +1, and here yj -1 and +1, that's a actually positively labeled and negatively labeled. So just consider what is that yj in the sense what, y in the sense that's actually labeled value. Okay, that's actually labeled value. So labeled value here, that is actually positive labeled. In here we have to just calculate the sum of the slack variable or for the negative labeled data set. Okay, negative labeled actually row. So that's actually slack variable value. Okay, so some of them values, some of all these values which are actually negatively labeled, some of all this value which is actually positively labeled. Okay, so we have not to do this actually imbalance thing. That formula will internally do this. So that's that. So that is actually how to deal with actually highly imbalanced data set. So that's another problem which we have to deal while we just use the SVM to develop the model. So that's the second thing. So now what we learn, up to this we learn two things: how to tuning the SVM parameters. So in SVM parameters, guys, we have to provide two different things, actually, the value of C and the kernel parameter. Okay, now another thing is starting to deal with actually SVM. Firstly, we have to be familiar, and that is actually, like, if you have categorized data, then you have to convert that categorized data in numerical. So how to convert that? So in this example, we have actually two different categorized value, male and female. So you have to like develop, otherwise you have to add two columns. You have to add two columns and remove the categorized column, and the first column with name male, second column with the name female with the column name. Okay, and like whatever the data having actually female value, put the 1 in that female column and 0 in male column, and vice and on so on. And second problem is we have to rescale the feature values. अगर आप ऐसा कुछ convert करते हो, ऐसा कुछ mapping करते हो, then you have to just rescale the other feature values. Why we have to rescale? Because some feature values having a higher value. Okay, जैसे यहाँ पे 150, 180, 185 था, जैसे यहाँ मेरे पास 0, 1 था. So we have to rescale that. So how to rescale that? That is actually also known as max min rescaling. That is also actually known as max min rescaling, max min rescaling. What we have to do, original value minus min divided by max minus min. Here there is a formula. Original value minus min divided by max minus min. That's the formula. So here we just mapped, just convert the feature like a matrix, and that matrix having actually a large number of otherwise that matrix, you can say that that will have actually large number of zeros. That means it is nothing but a sparse matrix actually. Now finally, these are the steps which we have to follow when we will deal with the SVM. First one, actually pre-processing, like scaling and numerical mapping. Pick up the RPF kernel. So how to choose the RPF kernel? So for that we have to divide the data set into training, testing, and actually validating. And finally, just like choose some value of C and like kernel parameter. What is that C and kernel parameter? C is a complexity parameter. And what about that? Actually, like kernel parameter depends on the kernel function. Just choose the proper value for them, and after that apply that, use the SVM and these two values of C and particular kernel parameter, like apply these values on, and like SVM algorithm train data set, develop the model. Now like input the validation data set in that model, and just find out the accuracy. Repeat this process and find out the best value of C and actually kernel parameter. Finally, merge the train data set and validation data set, and use the best value of C and sigma. Why sigma? Because I'm just discussing actually RBF kernel, and for the RBF kernel there is a sigma. So choose like use the best value of C and sigma. Also, like combine this data set, train and validation. So you will have actually 80% of training data set. Now you have actually best value of C and sigma. Now use all these and develop the actually model, SVM model. Now apply the 20% data set. Like now just put the 20% data set, that's actually testing data set, and find out the accuracy. So that is the thing. And how to choose the best value of C and sigma, we already discussed that also. And finally, last problem is nothing but, and maybe you will have actually highly, otherwise you have actually highly imbalanced class columns, class values in short. So how to deal with that? So we discussed that also. Now in the next session, what we will discuss actually SVM advantages, disadvantages, and finally we will actually sum up that. Okay, so that's actually up to SVM. And SVM disadvantages, advantages, in the sense we will discuss actually when we have actually multi-class problem, then what SVM can do. Otherwise, what we have to do with the SVM, if you have actually 3 class labels or 5 class labels, let us say 3 class label in the sense red, green, and blue. So now what to do when you just try to apply the SVM, because SVM is actually linear classifier. Linear classifier in the sense SVM having actually SVM having a power to deal with actually only 2 class labels. So whenever you have actually 3 class label or 4 class label, then what to do? And you want to just choose the SVM. So we will discuss actually like advantages and disadvantages of the SVMs, and finally we will start we will just develop the Python program to deal with the SVM. So guys, हो सके तो next session तक में एक बार